Hello, everyone. We're going to go over the homework for sections 3.1 and 3.2 now. In numbers 1 through 5, we're going to classify each situation as a percent problem, a percent increase problem, or a percent decrease problem. We're not going to solve it, though. Number 1, a $75 shirt is marked as 20% off. 20% off is a 20% decrease. This is a percent decrease problem. Number 2, after 7% sales tax, the total purchase price was $512. Sales tax is an increase on 100%. This is a percent increase problem. Number 3, in June, Brian earned $1,200 in commission on the $40,000 in sales that he secured for the company. This is a percent problem. We want to know what percent 1,200 is of 40,000. Commission is a percent problem. Number 4, a 35% markup on games earns the store 14 on each sale. A 35% markup would indicate a percent increase. And number 5, after a 40% off sale, last year's model refrigerator sold for $575. 40% off would be a percent decrease. In numbers 6 and 7 here, we want to solve the given percent or percent change problem. Number 6 asks, 42 is what percent of 96? We translate this directly. Is equals. Of is multiplication. What percent are unknown is x. So we have 42 equals x times 96. We can solve for x by dividing both sides by 96. 42 divided by 96 calculates as 0.4375. And since it asked what percent, but we have a decimal, we need to change our answer to a percentage by moving the decimal point 2 places to the right. We get 43.75%. In number 7, 35% of what value is 21? Again, directly translate. Of is multiplication. Is equals. What value are unknown is x. 35% needs to be written as a decimal, so move the decimal point 2 places to the left, we get 0.35. So this translated to 0.35 times x equals 21. We can solve for x by dividing both sides by 0.35, and 21 divided by 0.35 is 60. 35% of 60 is 21. Now notice our answer was just what we got when we did the division. We didn't have to change anything. We didn't have to move the decimal place at all, because in number 7, it asked for a value, but in number 6, it asked for a percent. So that's why we changed 6 to a percent, but we didn't do the same in number 7. Same instructions for number 8. 8 says, what is the percent change to go from 150 to 120? It is decreasing from 150 to 120, so this is going to be a decrease. To find the percent change, first we need the amount of change. 150 minus 120 gives us 30 as the amount of the change. And then the percent of change would be the amount of change over the initial amount. The initial amount we started with was 150. So 30 divided by 150 is 0.2. We want a percentage, so we change 0.2 to 20%. The percent change is a 20% decrease. Same instructions for 9 and 10. In number 9, we're asked, what is the value of 65 increased by 20%? This is a 20% increase. That would be 100 plus 20, or 120% of the value. So another way of asking the question, what is the value of 65 increased by 20%, is what is 120% of 65? Directly translating, what, our unknown, would be x, is equals, 120% as a decimal is 1.2, of is multiplication, and 65 is just 65. So this directly translated to x equals 1.2 times 65. That's a straight calculation. 1.2 times 65 is 78. So x is 78. The value of the value of 65 increased by 20% would be 78. Number 10, what value, when decreased by 15%, becomes 119? This is a 15% decrease. In other words, 100 minus 15, a percent decrease of 15% would be 85% of the value. So another way of asking the question in number 10 is 85% of what value is 119? This translates to 0.85 times x equals 119. We solve by dividing both sides by 0.85, and 119 divided by 0.85 gives us 140. So 140, when decreased by 15%, becomes 119. Number 11, using the 2018 single-payer federal tax income schedule shown here, determine the amount owed in taxes for the given taxable income, that is, income after any deductions. Then calculate the effective tax rate, round to the nearest percent. So in 11, we're given taxable income of $7,500, $7,500. That puts us in the first bracket, the 10% bracket. We pay $0 plus 10% of the amount over $0. In other words, $0 plus 10% of 7,500. That would be 0.1 times 7,500, or 750. 0 plus 750 is just $750. And remember, we find the effective tax rate by seeing what percentage this actually is of the taxable income. So 750 divided by 7,500 is 0.1, or 10%. So it looks like in the 10% bracket, you're paying an effective tax rate of 10%. And that makes sense because in that first tax bracket, unlike the rest of them, you're actually paying 10% of your entire taxable income, no matter where you are in the range. It's not until you hit the 12% tax bracket where you're paying 10% of the first 95.25 and 12% on anything over that the effective tax rate is going to be different than the tax bracket amount. Number 12, let's see this in action. 29,525 would fall here into the 12% tax bracket where we pay $952.50 plus 12% of the amount over $9,525. To find the amount over $9,525, we would subtract that. So 29,525 minus 9,525 is 20,000. So you're paying $952.50 plus 12% of 20,000. To calculate 12% of 20,000, that's 0.12 times 20,000, or 2,400, 2,400. Add to that the $952.50, and we get $3,352.50. So that's how much tax you would pay. To find the effective tax rate, we take that and divide it by the taxable income. $3,352.50 divided by $29,525 is 0.113, and then some more numbers, but we can round that off. You're paying an effective tax rate with this income of 11%. Why were we able to stop there? Well, because the directions told us to round to the nearest percent, not the nearest tenth of a percent, not the nearest hundredth of a percent, the nearest whole percentage. So that 3 tells us that the 11 does not round up. Number 13. Now we have a taxable income of $77,700. This puts us in the 22% tax bracket because it falls between 38.7 and 82.5. 77.7 is between these two values. We pay $4,453.50 plus 22% of the amount over 38,700. So to find the amount over 38,700, we would subtract it from 77,700, and 77,700 minus 38,700 is 39,000. Now we need to find 22% of 39,000. That's 0.22 times 39,000. That's 8,580. Add that to $4,453.50, and we get $13,033.50 in taxes. To find the effective tax rate, we divide that by the taxable income. 13,033.50 divided by 77,700 is 0.167, and then some more numbers, but that rounds us off to 17%. Number 14. Now we have a taxable income of $300,000. That's between 200,000 and 500,000, which puts us in the 35% tax bracket, where we pay $45,689.50 plus 35% of the amount over 200,000. To find the amount over 200,000, we subtract. 300,000 minus 200,000 is 100,000. And 35% of 100,000 is 0.35 times 100,000, or 35,000. Add that to the $45,689.50, and we get taxes of $80,689.50. To find the effective tax rate, divide that by the taxable income of 300,000, and we get 0.268 and some more numbers, but that 8 rounds the 6 up. We're rounding up to 27% as the effective tax rate. Number 15, you are a millionaire. Taxable income of $1 million. Anything over 500,000 puts you in the 37% tax bracket. In that tax bracket, we pay $150,689.50 plus 37% of the amount over 500,000. To find that amount, we subtract. 1 million minus 500,000 is 500,000. 37% of 500,000 is 0.37 times 500,000, which is 185,000. Add to that the $150,689.50, and we get taxes of $335,689.50. To find the effective tax rate, we divide that by the taxable income of $1 million. 335,689.50 divided by 1 million gives us 0.335 and some more numbers. That's enough to round us up to 34%. Let's take a look at number 16. A survey by the Boston Globe questioned elementary and middle school students about television. 68 students, or 42.5% of those surveyed, said that they had televisions in their bedrooms at home. How many students were included in the survey? So reading through this situation, we see that what we're being asked is to find this information. 68 is 42.5% of what number? 68 was a portion, a percentage of those surveyed. It was 42.5% of some number. So 68 is 42.5% of what number? We directly translate. Is becomes equals. Of becomes multiplication. 42.5% gets changed to a decimal, 0.425. So 68 equals 0.425 times x. To solve for x, we divide both sides by 0.425. 68 divided by 0.425 is 160. So 160 students were included in the survey. Number 17. Over a recent 40-year span, the consumption of eggs in the United States has decreased by 35%. In 1970, the average American consumed 400 eggs per year. Given this information, how many eggs would you expect the average American consumed per year in 2010? So we don't need the information about 1970 or 2010. That's just the 40-year span that's described. But over those 40 years, the consumption of eggs decreased by 35%. So this is a percent decrease problem. The original value was 400 eggs per year. A 35% decrease would be 100 minus 35, or 65% of the original value. So what we're basically being asked to find is what number is 65% of 400? What's the smaller value? 65% of 400. Direct translation would be x equals 0.65 times 400. And 0.65 times 400 calculates as 260. So in 2010, you would expect the average American consumed 260 eggs per year. Number 18. After a 1.75% cost of living increase to his salary, Bob will earn $41,208.75 this year. How much did Bob earn last year? So this is a percent increase problem. There was a 1.75% cost of living increase. 100 plus 1.75 would be 101.75% of the original value. The original value is what we're looking for. So what we know is that $41,208.75 is 101.75% of some number. So what we're looking for is the translation of $41,208.75 is 101.75% of what number? That translation would be 41,208.75 equals 1.0175 times X. 101.75 as a decimal would be, moving the decimal 2 spaces to the left, 1.0175. We solve for X by dividing both sides by 1.0175. And $41,208.75 divided by 1.0175 is $40,500. So Bob earned $40,500 last year. Number 19. Alice was just promised a 3.5% raise on her annual salary. She now will earn $58,477.50 next year. What was Alice's salary this year? So again, we're looking for the original value before a raise. We know what the future value is, $58,477.50. This is a percent increase problem. The 3.5% raise would add 3.5 to the 100, or 103.5% of the original value. So 103.5% of what number is 58,477.50? Of becomes multiplication, is becomes equals, 103.5% becomes 1.035. We have 1.035 times X equals 58,477.5. We can solve this by dividing both sides by 1.035, and 58,477.5 divided by 1.035 calculates to 56,500. So Alice's salary this year was $56,500. Number 20. At a 6% sales tax rate, Charlie was charged $67.20 in sales tax on his television purchase. What was the total cost to purchase the television after tax? Now, there are a couple of ways we can arrive at the final answer of total cost. One of them is by considering it a percent increase problem. A 6% increase would be 100.6 or 106% of the original price before sales tax. So no matter how we think of this, we need to know the original price before we can find the total cost. Sales tax rate 6%. The total amount of sales tax $67.20. So 6% of the original cost is going to be $67.20. We need to know 67.20 is 6% of what number? That translates to 67.20 equals 0.06 times X. Divide both sides by 0.06. 67.20 divided by 0.06 is 1,120. So the original price before sales tax is 1,120. That means that 106% of 1,120 would be the total cost. 106% of 1,120 is what number? That directly translates to 1.06 times 1,120 equals X. And 1.06 times 1,120 calculates to $1,187.20. So that would be the total cost. I said there were a couple of ways to come up with total cost. The other one would be once we have the original price, we can just add the sales tax onto that. And 1,120 plus $67.20 also gives us $1,187.20. Number 21. Thanks to a 35% off sale, Tim was able to purchase a new refrigerator for $1,755. What would the refrigerator have cost at full price? Well, this is a percent decrease problem, and a 35% decrease would be 100 minus 35, or 65% of the original price. 1,755 is 65% of what number? That's what we need to know. This directly translates to 1,755 equals 0.65 times X. We solve this by dividing both sides by 0.65, and 1,755 divided by 0.65 is 2,700. So at full price, the refrigerator would cost $2,700. Number 22. Wren works as an analyst where she earns $135,000 annually. Using the 2018 single-payer federal income tax schedule, and assuming that Wren takes the $12,000 standard deduction, determine the amount that Wren should expect to owe in taxes for 2018. Well, before we can figure out where this is in the income tax schedule, we need to find the taxable amount, which means we need to subtract the standard deduction from the total income. 135,000 minus 12,000 gives us 123,000. 123,000 puts Wren in the 24% tax bracket. And here, Wren will be paying $14,089.50 plus 24% of the amount over $82,500. To find that amount, we subtract 123,000 minus 82,500 is 40,500. 24% of 40,500 would be 0.24 times 40,500, which calculates as 9,720. Add to that the $14,089.50, and we get $23,809.50 in taxes. Number 23. Wren, from number 22, received a promotion halfway through 2018, which increased her salary to $175,500 for the year. How much more will Wren owe in taxes now compared to before she received her raise? Assume that she still takes the $12,000 standard deduction. So her new salary of $175,500 minus the standard deduction of $12,000 would be a taxable income of $163,500. This has now bumped Wren up into 32% tax bracket. Where she'll be paying $32,089.50 plus 32% of the amount over $157,500. To find that amount, we subtract from the taxable income 163,500 minus 157,500 is 6,000. So 32% of 6,000 would be 0.32 times 6,000, which would be 1,920. Add to that the $32,089.50, and Ren will be paying $34,009.50 in taxes now after the raise. Let's subtract from this the answer we got in the last problem, her taxes before the raise, which was $23,809.50. And now she will be paying $10,200 more in taxes. Now, this year, after the raise, she's making $175,500. Before, she was earning $135,000. That's $40,500 extra dollars in salary, but only $10,000 extra dollars in taxes, which makes sense because you're never hurt by taking a raise in terms of taxes. The extra taxes are more than covered by the increase in salary. Okay, that's the homework from 3.1. Moving on now to the homework from 3.2. And in exercises 1 and 2, we have the instructions to use the simple interest formula I equals PRT to find the unknown value. Round your response to the nearest cent if necessary. In number 1, we're given that P is 500, R is 0.12, and T is 7 years. We want to find I, so plug in what we know. PRT becomes 500 times 0.12 times 7, which calculates as $420. Number 2, we're given P is 925, R is 7.5%, and T is 4.5 years. Again, find I. Plugging in what we know, PRT becomes 925 times 0.075 times 4.5, which calculates to 312.1875, and rounded to the nearest cent, we have $312.19. Number 3, this time we're finding P. We're given I, R, and T. I is 42.5, R is 5%, T is 10 years. Plugging in what we know, we get 42.5 equals P times 0.05 times 10. 0.05 times 10 calculates to 0.5. So 42.5 equals P times 0.5. We can solve for P by dividing both sides by 0.5. 42.5 divided by 0.5 is $85. P is $85. Number 4, again, we're finding P. We're given I is 2,100. R is 10.5%. T is 4 years. Plugging in what we know, 2,100 equals P times 0.105 times 4. 0.105 times 4 is 0.42. So 2,100 equals P times 0.42. We can solve for P by dividing both sides by 0.42. 2,100 divided by 0.42 is 5,000. So $5,000 is P. And number 5, this time we're finding I, but T is given in months. Since there's 12 months in a year, 18 months would be 18/12 years. So t, when we plug it in, it's 18/12. There's no need to simplify that to 3/2 or 1.5 because we're just going to be putting this in the calculator anyway. Plugging in the rest of what we know, I equals 7,600 times 0.0525 times 18 divided by 12. That all calculates to $598.50. And if you're wondering where that rate came from, 5.25%, 5.14% would be 5.25%, which is 0.0525 as a decimal. Number 6, use the simple interest formula A equals P times 1 plus RT to find the unknown value. Round your response to the nearest cent if necessary. We're given P equals 5,250. R is 0.06. T is 5 years. We want to find A. So we write out our formula. A equals P times, in parentheses, 1 plus RT. Plug in what we know. To calculate, we start with the innermost parentheses. Multiplication first. 0.06 times 5 becomes 0.3. 1 plus 0.3 becomes 1.3. And 5,250 times 1.3 gives us A as 6,825. Number 7. We're using the same formula for A, but this time we're asked to find P. We're told that A is 5,850, R is 10%, T is 3 years. So the first step, write out the formula, and then plug in what we know. Substitute for A, substitute for R, substitute for T. Multiply R and T first. 0.1 times 3 is 0.3. 1 plus 0.3 is 1.3. Divide both sides by 1.3 to solve for P, and we get 5,850 divided by 1.3 is 4,500. So P is $4,500. Number 8. We're back to finding A, but this time, instead of being T given in years, T is given in months again. 18 months in years would be 18/12 years. Divide by 12 because there's 12 months in a year. Plugging in what we know for P, R, and T, making sure that we convert the 7.5% to a decimal, 0.075. First, take care of R times T. So 0.075 times 18 divided by 12 gives us 0.1125. 1 plus 0.1125 is 1.1125. And that times 12,000 gives us an answer of $13,350 for A. Number 9. We're finding P. We're given T in months again. 8 months in years. There's 12 months in a year, so divide by 12. T would be 8/12. R, 3.95%, must become a decimal, 0.0395. And A was 769.75. Plug all that in. We're solving for P, but we need to get P by itself. We need to take care of this other calculation. Start with R times T as always. 0.0395 times 8 divided by 12 gives us 0.026333333333333333333333. The threes repeat forever. Now we need a few of the threes because the more decimals we have, the more accurate our answer is. We'll see at the end, if we don't have enough threes, we're off by a few cents. But 1 plus 0.026, then a bunch of threes is 1.026, a bunch of threes. Divide both sides by 1.026333, and we get 750.000. $750 is P. But a note, if you got $750.02 or something similar, you just needed to add more threes into your calculation, and eventually it will come to 750 exactly. Number 10. This time, we're looking for I. But I isn't in the formula. What we don't have from the formula is P. So we need to find P, then we can use I equals PRT to find I. But we're going to use our A formula to find P first. A is 1,625. R is 12.5%, so 0.125. T is 5 years. It's given in years, so T is just 5. Let's find P first. Plug in what we know. Take care of R times T first. 0.125 times 5 is 0.625. 1 plus 0.625 is 1.625. Divide both sides by 1.625. 1625 divided by 1.625 is 1,000. So 1,000 is P. Now we can plug that into I equals PRT along with our R, along with our T. We get 1,000 times 0.125 times 5, which is 625. So I, what we were asked to find, is $625. In number 11, we're asked to find the average daily balance, and we're assuming a 30-day banking month. We're given that on day 1, there was a balance of $431, and it stayed that way for 15 days. On day 16, there was a transaction subtracting $312, and it stayed that way for 15 days. We need to complete the table. We need to know what the balance was for those second 15 days. 431 minus 312 gives us $119. So for 15 days, it was $431. For 15 days, it was $119. We need to find the average. So 431 times 15 plus 119 times 15, all divided by 30 for the 30 days in the month. That's 6,465 plus 1,785, which is 8,250. And when we divide that by 30, we get an average daily balance of $275. Number 12. We again have an incomplete table, but we're told that on day 1, there was a balance of $80. On day 11, there was a transaction of $38. And on day 21, there was a transaction of minus $118. So we need to figure out what the balances were and for how long. From day 1 to day 11, that's 10 days. From day 11 to day 21, that's 10 days. And from day 21 to through day 30 is 10 days. So days 1 through 10, days 11 through 20, days 21 through 30, 10 days apiece. The $80 that we started with and then adding 38 more gives us $118. And then the $118 minus the $118 gives us $0. So for 10 days, we had a balance of $80. For 10 days, we had a balance of $118. And for 10 days, we had a balance of $0. Setting up the average, 80 times 10 plus 118 times 10 plus 0 times 10, all over 30. That's 800 plus 1,180 plus 0, or 1,980. Divide that by 30, and we get an average daily balance of $66. Number 13. If the credit card from number 12 charges a 24% annual finance fee, determine the finance charge for the month's usage in number 12. So we need the average daily balance from number 12. And that was $66. That's P, that's our principal. R, our rate of 24% annually, as a decimal is 0.24. And T, since this is only for 1 month, is going to be 1/12. Remember, when it's in months, we need to divide by 12 to account for 12 months in a year. 1 month is 1/12 of a year. Plugging in, I equals PRT. I equals 66 times 0.24 times 1 divided by 12. And that calculates to 1.32, $1.32 finance fee. Now, you might be thinking, well, we ended the month with a $0 balance. Doesn't that mean that there's no finance fee? That does not mean that. The following month will have no finance fee because it will begin with a $0 balance. But ending with a $0 balance does not necessarily mean that there is no finance fee. You have to start the month with a $0 balance to have no finance fee. Number 14. On day 1, there's a balance of $27. On day 2, there's a payment of $27. On day 25, there's a transaction that adds another $476. And on day 28, there's a transaction that pays off that $476. Filling in the rest of our table, we need balances, we need durations. Day 1 was a balance of $27, and it stayed that way for 1 day. Then on day 2, paid off that $27, leaving a balance of 0, and it stayed that way for 23 days, day 2 through day 24. On day 25, there was a transaction of $476, giving us a $476 balance, and stayed that way for 3 days, day 25, day 26, and day 27. On day 28, that $476 was paid off, leaving a $0 balance, And it stayed that way for 3 days, day 28, day 29, and day 30. So a balance of $27 for one day, 0 for 23 days, $476 for 3 days, and $0 for 3 days. Setting up the average, that's 27 times 1 plus 0 times 23 plus 476 times 3 plus 0 times 3. Divide that by 30. We get 27 plus 0 plus 1,428 plus 0, which is 1,455. And when we divide that by 30, we get an average daily balance of $48.50. Number 15. If the credit card from 14 charges a 29.4% annual finance fee, determine the finance charge for the month's usage detailed in number 14. So we're looking for I, we know PR and T. P is the average daily balance that we had in the last problem, $48.50. R is our 29.4% finance fee percentage as a decimal, 0.294. And T, since we're only dealing with 1 month, is 1/12 of a year. Plugging in what we know into I equals PRT, we get 48.50 times 0.294 times 1 divided by 12. That gives us 1.18825 rounded to the nearest cent. That's $1.19. So there will be a $1.19 finance fee this month. And once again, the following month would have no finance fee because it will begin with a 0 balance. Number 16. Dana takes out a loan of $9,500 with an effective interest rate of 6.5% in order to purchase a new car. If she pays off the loan over the course of 1 year, how much simple interest will she owe? We're told that it's simple interest. That's I equals PRT. P is 9,500. R is our percentage as a decimal, 0.065. And since we're talking about 1 year, T is 1. Plugging in what we know. I equals 9,500 times 0.065 times 1, which calculates to $617.50. Number 17. Carl is planning to take out a $975 payday loan for 15 days at 32% simple interest annually. How much will it cost to repay the loan? Since we want to know how much it'll cost to repay, that means we're looking for A, the principal plus the interest. We can either find I and then add I to P to get A, or we could use our A formula. Let's go ahead and do the A formula first. A equals P times 1 plus RT. P is 975. R is 32%. As a decimal, that's 0.32. And T, since it's 15 days, and there's 360 days in a banking year, T is 15 over 360. Plugging in what we know. Plug in for P, plug in for R, plug in for T. Take care of R times T first. 0.32 times 15 divided by 360 gives us 0.01333333333. 1 plus 0.01333 is 1.01333. Times that by 975, and we get 987.99675, which rounds to $988. The other way to do this is to find I first, just find the interest. P times R times T, 975 times 0.32 times 15 divided by 360 gives us $13 for I. The principal plus the interest, 975 plus 13, also gives us $988. Number 18, looking back at her car loan, Liz realized that she had paid $5,040 in interest over the 6 years it took for her to pay back her car loan. If the loan was at 7% simple interest annually, what was the principal amount of the loan? So we're looking for P. We know that I is 5,040. We know that R is 7%, so that's 0.07 as a decimal. And T, the amount of time in years, is 6. Plugging in what we know, that gives us 5,040 equals P times 0.07 times 6. 0.07 times 6 is 0.42. So we can solve this for P by dividing both sides by 0.42. 5,040 divided by 0.42 is 12,000. So the principal amount of the loan was $12,000. Number 19. In order to pay off a home improvement loan, Aaron needs to make payments of $325 each month for 48 months, for a total cost of $15,600 to pay off the loan. If the loan was at 6.7% simple interest annually, how much did Aaron initially take out for the loan? So we're looking for how much she initially took out. That means we're looking for the principal. A, the total payoff was $15,600. R, the rate, 6.7% becomes 0.067 as a decimal. And T, since this is in months, we divide by 12, 48 over 12. No need to simplify that to 4 because we're just putting this stuff in a calculator anyway. You can't do these problems without a calculator. Plugging in what we know, substitute for A, substitute for R, substitute for T. Take care of R times T first. 0.067 times 48 divided by 12 gives us 0.268. 1 plus 0.268 is 1.268. Solving for P by dividing both sides by 1.268. 15,600 divided by 1.268 is 12,302.839, and some more digits that don't matter, but that 9 was important because it rounds us up to 84 cents. $12,302.84. Number 20. All told, it cost Sergey $5,695 to pay off his $4,700 loan at 4.7% simple interest annually. How much did Sergey pay in interest on the loan? So if we start looking for our variables, we're looking for the amount of interest. We know that A, the payoff, is $5,695. We know that P, the principal, is $4,700. We know that the rate is 4.7%. Turns out that that rate is not actually needed, and T isn't even available here, which should be a clue that we don't need to use a simple interest formula. Instead, we could use our formula that the payoff is the principal plus the interest. A equals P plus I. We have A and P. We're looking for I, so plug in what we know. 5,695 equals 4,700 plus I. Solve by subtracting 4,700 from both sides, and 5,695 minus 4,700 is 995. So Sergey paid $995 in interest. Number 21. Steve has an unpaid balance of $433.75 on his credit card at the start of the month. 15 days into the month, he paid off $237.85, leaving him with a balance of $195.90 for the last 15 days of the month. If Steve's credit card has a 32% annual interest rate, what will the financing fee be for the month? Now here we need to take everything that's in the words and we need to put it into the table. On day one, there was a balance of $433.75. It stayed that way for 15 days. 15 days into the month, he paid off $237.85, so that's a subtraction, leaving him with a balance of $195.90 for the last 15 days of the month. Set up the balance, set up the average. 433.75 times 15 plus 195.90 times 15. That's 6,506.25 plus 2,938.50, which is 9,444.75. Divide that by 30, that gives us 314.825, which rounds to the nearest cent as $314.83. That's the average daily balance, not the financing fee. So we need to continue. We want to know what the interest is when the principal is the average daily balance we just found, $314.83. The rate is 32%, 0.32 is a decimal. And since we're dealing with just 1 month, the time is 1/12. 1/12 of a year is 1 month. Plug what we know into I equals PRT. P is 314.83, R is 0.32, T is 1/12. We go 314.83 times 0.32 times 1 divided by 12. And that gives us 8.395 and some more digits we don't care about, but the 5 is important because it rounds us up to 40 cents. The interest, the financing fee for the month is $8.40. And finally, number 22. The transactions on Jim's credit card for the month of November are listed below. If Jim's credit card charges a 33.3% annual finance fee, what will the finance charge for November be? Now, luckily, we don't have to go ahead and make our table here because of one simple thing. Day one, the starting balance was $0. When you start the month with a 0 balance, there will be no finance charge. So the answer to this question is $0. That's the homework for 3.2. Next time I see you, we're going to cover section 3.3.